All right, good evening, everybody. System Chalk with part four, hopefully part 4 and 5, but we'll see how things go for the roguelike. Sorry, the roguelike dev does the complete roguelike tutorial. So technically, we're still into week 2, but what I thought I would do here, number one, this is actually a little bit habit forming, which I think is a good place to be. So I am kind of caught up to where the previous episodes were, and I put those online. But I don't know. I feel like I'm on a little bit of a roll, and I thought I would maybe try and get a head start on this week's work. And it's mostly, I won't put them live ahead of time or anything like that, but I had a little bit of extra time, and it's a wonderful way to avoid doing all the things I should be doing with the time anyway. But as seems to be a bit of a habit for this series, what I'm going to do is deal with some of the questions that were around or that were remaining from the previous session. Now, I don't really think there was all that much for me to follow up on. There were a few things which were sort of lingering questions, but these would be more long-term questions for me. So, for instance, this would be something like the future module, how the annotation in there will affect the overall program. And I have a little bit of a hint in terms of how this will work. So what I mean by that is I sort of know that the time at which I think it's entity or engs, one of those two. There will be, in terms of the type hinting, there will be a difference in terms of when it's checked and basically whether or not it will cause a problem when I try to run the program. So again, the first question was going to be, at what point does that become just a regular behavior in terms of Python? And then sort of second of all, how do I just navigate what this thing is doing, because it wasn't really elaborated on in terms of the tutorial. And that's just that's down the road. It's important. I should understand it, particularly if I'm going to start including some more type hints. That is not something that's essential for me to move forward. So I'm leaving that aside. But one question that I didn't deal with previously was this idea of checking the movement. I think it was in, I can't remember what it was in actually. It was either input handlers or engine. It was where we were dealing with the movement. So I think actually might be actions. Yes, here we go. Okay, so this one was kind of an interesting one. So my usual understanding of, do I have it in here? Yeah, I was wondering if I actually worked this out in like a notepad to see how all the different relationships work, but I didn't. Actually, you know what? We can. Okay. So normally when I'll use NumPy, we'll make just a simple little matrix here. So you got 1, 2, 3. Actually here. Not quite how this works, but it's gonna be a convenient illusion for us to work with. Okay, so basically, whenever I'm going to be using NumPy, I'm going to be usually working with something like this, and we'll say that these opening brackets are so that I can navigate the rows, and then there's going to be navigating a column. I'm not 100% sure this is what it would look like if I were to print the matrix in, like if I were to put a print statement inside of this program. But we can get some pretty clear ideas in terms of how this thing would work, right? So if I want to try and take the element at 0, 0, I'm basically going to be getting this 1 here. And if I want to move on, maybe I want to take, let's say 1, 1. Okay, well, we move along the diagonal. And then, of course, if I go for 0, 1, then I would be getting 2. And basically, this is just a question of making sure that I understand what sort of dimension I'm moving along in terms of these numbers. And you can also sort of see how this generalizes, right? The interesting stuff in terms of NumPy is usually not when you're dealing with these 2D matrices, something that looks like a chessboard. It's where you're sort of dealing with these n-dimensional matrices where you're like, okay, as a human being, I have absolutely no idea what this thing looks like, but I know there are, it does very useful things, right? So, statistics, you have all of these different characteristics that you're sort of trying to account for. And, it's completely ordinary to think about, let's say a 32-dimensional matrix, just because that's the problem you're working with, and you happen to need all of those. It's not maybe necessary that you be able to visualize it. It's necessary that you understand how the math works and that it can generalize to the specific problem that you're looking for. And that's kind of what I ran into here, right? Like the roguelike is a two-dimensional game. I haven't really been thinking of a lot of cases where excuse me. I haven't been really thinking of a lot of cases where I would maybe need more information. And so I had, I learned a little something about NumPy, actually, looking into this. So my understanding of how this specific line in, if not engine game map tiles, walkable dest X, dest Y. So let's just change our perspective a little bit on this. So what I've been describing so far does a very good job of explaining this sort of selector here, right? And in the previous episode, we talked a bit about the slices. So, you have that example where you do, 1:3, and it's going to pull out those two elements. And that's basically what's going on here. So I think we've kind of had a decent enough explanation in terms of how that works. It's a very intuitive way of thinking about this problem. And what was weird was thinking about this walkable. And where this really becomes a thing was actually back in the D-type definition. So I think that would be in game map right here. Oh, maybe not. Tile types. All right, so this comes back to where we had tile DT. So this is the tile data type, NPD type, and this is one of three. There's sort of three things that we have here, right? We've got walkable, which is represented as a Boolean. We've got transparent, which is interpretable as a Boolean. And then we've got dark, which is basically an instruction in terms of how to graphically represent it. So when it's not in the field of view. So this winds up being where I sort of struggled with the idea, or with the ideas in this program. So what might be a little more helpful to think about here is that these numbers are not really there. In fact, they're sort of holding on to some other information. So we say this is, maybe A, B, C, D, E, F, G, H, call this J. I know there's supposed to be I, but I don't, too close to 1. I actually already made this problem with my password earlier. And so what we're going to say here is that each of these letters can have one of three pieces of information. And those pieces of information are walkable, transparent, or dark. And it depends on the context. So if I say, okay, give me the walkables, all of a sudden this thing, sorry. Oh God. Sorry, just give me a second here. There we go. So, right, and then we get something like, I'll just use T's and F's. Actually, let's say there's a wall around the, Okay, so, very small room, only one walkable tile. And then we say, okay, well, maybe I'm not interested in walkable. Let's ask if it's transparent. And let's say maybe there's windows in each of the, the cardinal directions. So let's say that if we were curious about transparent, we could say, we can look out the north window, the east, west, south window, but we can't look out the diagonals. So these are the Booleans, right? I'm not going to bother with the, oops. Not going to bother with the graphic just because that's a little more complicated. I think that'll have a set of numbers in that. But you can kind of see, right, how this board has information. It has information other than just whether or not I can cross over. Based on the context, this is what I need to know. And this is where I really got tripped up. So it's not necessarily another dimension. But rather what I'm doing is I'm unpacking. I'm first of all saying is like, okay, we have all of these different tiles in this matrix. And what I'm most curious about right now is their walkable status. So we go from A, B, C, D, E, F, G, H, J. We say, okay, tell me what their status is as far as walkable is concerned. And because these are represented as Booleans, we now have this matrix. And then having now transformed this into something that tells us about the walkable status, now we can say, okay, I'm going to give you an X and Y coordinate, and I want you to tell me whether or not this is walkable. And that's what makes this work. It's not that I ever doubted that this doesn't work. This was something that, clearly did. I wouldn't be able to run the program and sort of predict the behavior of the character. But for me, I was trying to understand why there were those two slices. Basically, I just went and took a look. So we eventually got to dtype, describes how bytes in a fixed size block of memory corresponding to an array item should be interpreted. And then if you sort of scroll down here, I think it gives an example where, there's the data type name, but I thought there was an example in here that really made it clear in my head. Suffice to say, I read this a little bit more thoroughly on my own time. I suppose just to avoid spending all of the time on this. So this is a little bit like what I'm looking for. In this particular case here, we're pulling out a specific element out of the array. After we take that specific element of the array, we're saying, okay, tell me about the grades. And really, in the program, we're just doing it the other way around. We're saying, turn that matrix into a whole bunch of information. Turn that matrix into the walkable status, and then give me that specific index. In fact, based on this example here, I kind of think I could switch it around and the behavior should be the same. But it's not an experiment I'm curious enough with. But like I said, I learned something about it. So it's not a situation that I've normally had to deal with. Like I said, a lot of my applications are very dull. I don't need to define these strange little data structures. But that was a lingering problem that I was able to sort of get a handle on, partly because I wrote a note to myself. But I think that's all of that. So 15 minutes of catching up. I'm feeling pretty good in terms of being able to explain most of how this works. There's a couple things here where I just sort of rely that load tile sheet, does what it says it does. In terms of sort of rendering, again, I'm basically just taking Tcod at its word that it's got that sort of stuff handled, but that's why you use libraries like that. In terms of the basics of saying, how is this world represented in data, I feel like I'd be able to answer most of the kinds of pop quizzes that I might throw at myself. Okay, on to field of view. We have a dungeon now, and we can move about it freely, but are we really exploring the dungeon if we can see it all from the beginning? Most roguelikes, not all, only let you see within a certain range of your character, and ours will be no different. We need to implement a way to calculate the field of view for our adventurer, and fortunately, TCOD makes that easy. When walking around the dungeon, there will essentially be 3 states a tile can be in related to our field of view: visible, and not visible but previously seen. What this means is that we should draw the visible tiles as well as the not visible but previously seen ones to the screen, but differentiate them somehow. The not visible tiles can simply be drawn as an empty tile, while with the color black, gray, or whatever you want to use. In order to differentiate between these tiles, we'll need 2 new NumPy arrays, one to keep track of the tiles that are currently visible, and another to keep track of all of the tiles that our character has seen before. Add the 2 arrays to game map like this. So you can kind of see why talking about the data types is relevant, seeing as we are going to be playing around with game map a little bit more. Okay, here we go. So under self tiles, this is in init where we're defining the game map. Self visible, be full, width, height, fill value is false. Keep the same order as all the other ones. There's a comment here which says, and then, what one was this one again? Explored. And same trick here, we'll do np full, width, height, fill value, false, order F, tiles the player has seen before. And I think these kind of make sense on their own, right? So essentially we're initializing both visible and explored as tiles. Everything is false, and essentially we're going to let the game in the initial state there may not even be a player to see anything. So in this case, we sort of say, all right, everything starts off as false, and we're going to have some intervention in the game that will change the state of these tiles. So we create 2 arrays, visible and explored, and fill them with the value false. In a moment, we'll create a function that will update these arrays based on what's in the field of view. Let's turn our attention back to the tile types. Remember when we specified the walkable, transparent, and dark attributes? We called it dark because it's what the tile will look like when it's not in the field of view. But what about when it is? For that, we'll want a new graphic DT in the tile DT type called light. We can add that by modifying the tiletypes.py like this. We need to adjust the new tile method. Presumably it's a tuple like its partner up there. Excuse me. And then we adjust for light. Okay, now shroud represents unexplored, unseen tiles. I'm wondering here if the capital letters are indicating a constant. So this is the code for the ord is basically the it gets me the character that it's working with. And then, all right. Finally, new tile. We're completely changing this. So new line for everything. And then same story with this one, sort of expanding it out because it's getting a bit long, and we'll have to add our light. I added one too many parentheses. Okay, we've got Ord, we've got these guys. I'll live with it. Okay, so essentially this seems like many more changes. I mean, obviously the number of lines has expanded, but it's just so that we can see a little bit more. Not 100% sure how the shroud is being used right now. In fact, it's also not complaining. Huh. This is interesting. So normally it complains when a variable isn't used. I'm thinking I messed up with my tools. All right. Well, I'm not going to complain about that. We don't seem to have used the shroud, which again, this is going to be sort of the fog of war that we've talked about before. But all of the changes here just reflect this new value. So you can sort of think almost that our field of view is going to be sort of like a flashlight almost. You know, you're sort of waving around and you're seeing it, and then you have sort of this residual memory of what the tile was, which is this dark value here. Let's go through the new additions. So to the D types, we're adding a new graphic DT to tile DT that we use to define our tiles. Light will hold the information about what the tile looks like when it's in the field of view. We've, modified the new tile function to account for the new light attribute. Light works the same way as dark. Shroud is what we'll use for when a tile is neither in view nor has been explored. It's just set to draw a black tile. And finally, we add light to both the floor and wall tiles. We also modify the functions to fit better on the screen, adding new lines after each argument. This is just for the sake of readability. I guess technically they added a comma at the end of this one. I should add that too. Light in both cases is set to a brighter color so that when we draw the field of view to the screen, the player can easily differentiate between what's in view and what's not. As usual, feel free to play with the color schemes to match whatever you might have in mind. With all that in place, we need to modify the way game map draws itself on the screen. So here, this is in render. Right now, it just has console tiles RGB. Now, obviously, we changed tiles RGB to RGB based on the warning that it gave us. So we'll add the doc string. Renders the map. If a tile is in the visible array, then draw it with the light colors. We're not savages here. We spell colors with a U. If it isn't, but it's in the explored array, then draw it with the dark colors. Otherwise, default is shroud. Now, I never really explained this, but for these doc strings, basically in Python, if you do, so technically you don't actually need to do this. This is just one line, but what the 3 quotation marks will do here is this allows you to do sort of multi-line comments. So just it's easier to show how this, when this doesn't work. So okay, sure, hi max rooms. The rooms family is a long and respected name. So you'll notice here, right, it's going to tell me some errors here in terms of saying that, simple statements must be separated by new lines or semicolons. We just have a single quote here, which doesn't have a matching quote. It's basically not treating this as the string I want it to be. All those errors go away as soon as I add the 3 quotes, because it allows me to add text in between the two. So these are really helpful for doc strings that go for more than one line. I believe if you have a doc string that goes for one line, traditionally you just use the one quote. Although I'll be honest, like this is kind of nice just because it tells me, hey, this is a doc string for it. It's a one-liner. I obviously struggle with brevity, so I almost never have one lines, but I still think this is kind of helpful just to let me know it's a doc string, especially for some of this stuff where it isn't always commented. Anyways, let's get on to the meat of the matter. So the removal here is a little misleading, right? So 0 self width, 0 self height, all of this is the same. And obviously we're not replacing RGB with tiles RGB, but we do change. So we've got NP select now. So we're changing starting here. So NP select. Now this is a new one for us, so if we want, we can actually take a look. So return an array drawn from elements in a choice list depending on conditions, and a lot of this will be unpacking the conditions. Again, this is not necessarily one that I use all that frequently, but I think we're going to understand the from the context. It's kind of clear what we're doing here. So conlist is self-visible, self-explored. Choice list is self-tiles light, tiles dark, default. Okay. So this is one of these cases. So this is something that probably, if you were to sit down and see this outside of any context, this might be a little hard to understand. But between the description up here and the doc string, this is kind of self-explanatory. I shouldn't call it self-explanatory when it isn't, but this is something that just sort of makes sense, right? There's one of 3 states that this can be in. It can be currently in the field of view. It can be something that you've seen before, or it can be something brand new. So default is something brand new. Otherwise, you've been seen, or you're visible, or you're not visible. And that's basically what I'm assuming they're going to say here. So the first part of the statement, console tiles RGB, 0 to self width, 0 to self height hasn't changed, but instead of just setting it to self tiles dark, we're using NP select. NP select allows us to conditionally draw the tiles we want based on what's specified in conlist. Since we're passing self-visible, self-explored, it will check if the tile being drawn is either visible, then explored. If it's visible, it uses the first value in choice list, in that case, self-tiles light. If it's not visible but explored, we then draw self-tiles dark. If neither is true, we use the default argument, which is just the shroud we defined earlier. So the reason why I probably should have done a better job explaining select, but there's something that's quite useful that's being done here. And this is one of the reasons why NumPy is a really helpful one to understand, even if it's a bit counterintuitive from how you might normally use Python. One way you could imagine this, so let's just say you have, I don't know, you're making a chess game or a tic-tac-toe or something like that, and you define your board You define your board through a list of lists, right? Well, that's not that different from having an array in NumPy. But the difference is usually when you try to make those sorts of changes, or when you try to basically do what we're doing here, the really natural way of thinking of that problem is to write a for loop and then a for loop. And you basically go tile by tile, saying it's like, okay, are you, right? So 0, 0. Are you visible? Are you explored? No? Okay, shroud. Then tile 2. Are you visible? Are you explored? No? Then shroud. And you do that over how many times? And, say, oh, this is great. This game is so popular. We're now going to do this on a 4K monitor, right? This is not great. And this is one of the reasons why NumPy exists, basically, is you can sort of say, it's like, okay, I have a whole bunch of tiles, and I want to basically do this one action on all the tiles. And again, as we talked about, it's basically a nice little convenience layer over C, and you get all the advantages in terms of saying, it's like, okay, I've defined this big block. Here are some conditional behaviors that I want for it. Have at it. And you basically just get to deal with the board as a single entity, as opposed to the more natural way, especially when you're first learning. And again, I don't mean to present myself as a big Python expert, but basically you move from that initial impression of saying, I'm going to be a bit of a control freak and handle each individual tile myself. You get to sort of think of the bigger picture and say, okay, this is the whole board, and this is the change we're making to the whole board. Okay, if you run the project now, none of the tiles will be drawn to the screen. This is because we need a way to actually modify the visible and explored tiles. Let's modify the engine to do just that. So for illustration, let's actually take a look at what it looks like. Of course, it would help if I was in the main, right? So it's kind of dark in here. And I have absolutely no way of knowing whether I'm walking into walls or not, but this is, hey, we've got our first extension, right? The dark game. How can you find your way through the level? At the very least, we know there's an enemy here. Maybe this isn't an enemy. Maybe this is one of those dramatic scenes where you need to find your beloved and you're not quite sure, you've grown apart, or you can't communicate with each other, and it really feels like I'm about to get in there, but no, we don't have a path to them. Oh, this is tragic. Anyways, let's make this so we can take a look around. And as the game anticipated, right, we need to actually, we said earlier, the tutorials now said, we actually need to let the game determine the changes for these things. So let's go into engine as it instructs us and make the change. So we need to add another tcod module. I'm quite grateful for this thing because from what I have heard, computing field of view can get very expensive very quickly, and I love it when smarter people than me solve problems. Okay, so handle events, we've got perform action, and now we need self update FOV. And now we actually need to write the update FOV. So this is taking a slice of the visible game map. So it's good that we took the time to learn how this works, because this isn't confusing anymore, right? So we're taking that tile, we're taking the tiles out of game map, and we're saying, remember how I did that image where we said from the cardinal directions, which ones can we look through? Well, this is the part that's saying, where are the windows? All right. If tile is visible, it should be added to explored. Really loves adding .abs. Oh, that's an interesting one. So, right. Okay, yeah. So, you can think of this, right? Remember how we said plus equals is addition on itself. Or equals presumably does the same thing with or. So does this make sense, right? Well, remember that an or, like true is kind of this absorbing state for or. So if it's true at one point, it's always going to be true. It's the and that messes with it. So what happens if you've explored before? Well, you don't even evaluate it, right? You already have your true. If you hadn't seen it before, but it was true before, it was true after, well, you've looked at the second part, but now it's become true, and it will always stay true. And then finally, if it wasn't checked before, it was false before, you're still going to check both, because again, it looks for the first true, or it waits until it's done. And then for the parts of the map that you haven't seen, it that stays false. So I would have to imagine, now again, I don't expect that this would be something that would slow down the game, but I have to imagine if you were to just like really blow up the number of tiles, this would be a case where you'd maybe see the game get better the more of the map that you explored. So at the start, it would probably be rather slow because it's doing all those comparisons for the ones that are not true already. I could be wrong though, right? Like I don't actually know how expensive it is to compare these things. And obviously, comparing true and false is not that hard. So like I'm imagining, I don't know, an IMAX screen with a DPI of 10,000 or something like that, or PPI of 10,000 or something, this is just me this is me thinking of silly examples to try and say, okay, if this works the way I understand it, what are the conditions? What are some things that I would expect to happen? And sometimes just doing really extreme examples are helpful. Obviously, none of this stuff. I hope this is apparent. None of this should be thought of like quote unquote optimizations, right? I'm trying to remember. I think it was like Don Knuth or something like that, where premature optimization is the root of all evil or something along those lines. And let's face it, I'm not good enough to optimize anything. So I'm definitely not the person to call for that sort of stuff. Okay. We are still going to do console print, it looks like. So for entity in self entities, only print entities that are in the FOV. If self game map visible Y. And I think that's it. Oops. All right, the most important part of our additions is the update FOV function. We're setting the game's map visible tiles to equal the result of compute FOV. We're giving compute FOV 3 arguments, which it uses to compute our field of view. Transparency, this is the first argument which we're passing. Self-game map tiles transparent. Transparency takes a 2D numpy array and considers any non-zero values to be transparent. This is the array it uses to calculate the field of view. POV, the origin point for the field of view, which is a 2D index. We use the player's X and Y position here, and radius, how far the FOV extends. And that's just hard-coded as 8. That might be something that we probably would want to put, I don't know if we'd put that in main, but it's the sort of thing that you can imagine we would put. I think it said that it was going to have like a JSON file with all of the values, but you could definitely see this being something that you would put in a file somewhere else so that you can just adjust those quite simply on the, in one place. Probably also things like, maximum number of rooms and things like that. But There's more that this function can do, including not lighting up walls and using different algorithms to calculate field of view. If you're interested, of course I'm interesting. If you're interested, you can find the documentation here. And again, this is something that would be really interesting to read at some point. But again, what I want to do is I want to finish this tutorial, and then I'd maybe like to sit down with this library and say, okay, so what are some of the cool things that I wasn't aware about, rather than kind of get bogged down reading of all the different options. It's exciting to sort of see the map. So maybe one of the things I would want to mess with first is the different types of procedural generation. And with that, that doesn't involve any knowledge of TCOD. That's purely, how am I going to put the rooms on the map? Or maybe I want to move beyond rooms. Maybe I want to think of something else. So you pick your battles in terms of what you find most interesting, but definitely one that I want to follow up on at some point. The line self game map explored or equals self game map visible sets the explored array to include everything in the visible array plus whatever it already had. This means that any tile the player can see, the player has also explored. That's all that we need to update our field of view. Notice that we call the function whenever we initialize the engine class, so that the field of view is created before the player can move and after handling an action, so that whenever the player does move, the field of view will be updated. Lastly, we modify the part that draws the entities so that only entities in the field of view are drawn. Run the project now and you'll see something like this. So I didn't want to scroll too far down because I think it'll be interesting to see what this looks like for the first time. Hey, there you go. Now this is really neat, right? Like this is the sort of thing where I'm like, yeah, I'm really glad smarter people than me figured out, because like it is kind of neat to see the light work like this, right? So you can also imagine, like this is one of the things that also gets kind of exciting, because you can kind of imagine the moments, right? You go walking by the room and there's something there. There's definitely some fun that you can have with that. But the other thing that's kind of neat too, right, is you just kind of walk by. It's like, wait a minute, it looks like there was another opportunity for exploration. So we've gone from just being able to run around this map, which is kind of neat. But what we've done now, even just through the addition of field of view, this is now starting to take some of those characteristics that make the opening turns of Civilization so enjoyable, right? You have this big map, you have all this possibility, you don't know what it looks like, and your opening moments are just figuring out what it's like. Now, of course, this is a roguelike, so it's a big dungeon full of dangerous things that want to hurt you, but there's definitely something kind of fun about this, even though we had the fun of setting up the map before. And I'm not going to lie, it was kind of fun to see all of these rooms set up. This process of being able to sort of run around and see. Actually, you know what? The other thing, I don't see the NPC, but I imagine that's because they're probably in a wall somewhere. So let's try running this again and see if we can see the NPC. It kind of depends on it being rendered in the right spot. So I'm guessing this one isn't a good candidate. We'll try maybe one or two more times. This could be... There we go. Stuck in a wall, but... Hello. But yeah, I don't know. Like I said, I mean, I'm too easily amused, to be completely honest. But there's something... To me, this is the sort of reason why you do little tutorials like this, right? This is a lot of fun to just sort of go around and, you have that... And again, I think there's a big compliment that the author of this tutorial deserves. There's something about timing the beats of these moments, or sorry, timing these beats just so that you have that nice moment of like, it's nice and early in the tutorial. Oh, hey, I've got a map and it's generating, and even I don't know what's going to be out there. So that's kind of an exciting moment, and you get to experience that. But on top of this, now I have this moment of, oh, okay, not only am I seeing the map, but I don't even know what the map looks like. I actually have to go running around here and see what's going on. And again, you have this option of running in and changing the radius, and they point you to other methods to calculate the field of view. Lots of just neat little things to see inside here. So, all right, that's enough play. Hard to believe, but that's all we need to do for a functioning field of view. This chapter was a shorter one, but we've accomplished quite a lot. Our dungeon feels a lot more mysterious, and in coming chapters, it will get a lot more dangerous. If you want to see the code so far in its entirety, click here. So we're going to bank our short tutorial in the form of an update. So we're not syncing the changes because we're not done for our session tonight, but clearly we have enough time to move into part 5. Now this looks like a little bit of a longer one just based on the text. It may just be because there's lots of code, but we'll see if we can get through. We'll see if we can get through this one in one session. Part 5: placing enemies and kicking them harmlessly. What good is a dungeon with no monsters to bash? This chapter will focus on placing enemies throughout the dungeon and setting them up to be attacked. The actual attacking part we'll save for next time. When we're building our dungeon, we'll need to place the enemies in the rooms. In order to do that, we need to make a change to the way that entities are stored in our game. Currently, they're saved in the engine class. However, for the sake of placing enemies in the dungeon, and when we get to the part where we move between dungeon floors, it will be better to store them in the game map class. That way, the map has access to the entities directly, and we can preserve which entities are on which floors fairly easily. Start by modifying the game map. So this is one of these cases where they're adding future. I always pay attention to these now because they might indicate to me when we need to worry about importing annotations. And in fact, I'll go so far as to say I haven't seen a case where we import sort of typing iterable type checking. It looks like each time we add in entity, that's where it's getting cranky. So I'm willing to guess that's related, but again, that's not going to be an extensive search that I do. It's just something I want to keep an eye on. Okay, so we're adding some parameters to game map. And of course, you get a little bit of a hint based on the imports. And this is worth noting. I think this is the first time that we've given it a default argument. So in this case, it's an empty tuple for entities. But presumably, we'll be giving it more than just the empty tuple when the time comes. Okay, self width. So we'll add self entities, set entities. So same logic as before in terms of the entities. Doesn't make sense to have more than one entity, and so sets will automatically remove duplicates. Then let's modify engine to remove the entities from it. Sorry. Just don't need set. And then you go away. And you go away. Because we've modified the definition of engine init, we need to modify main.py where we create our game map variable. We might as well remove that NPC as well since we won't be needing it anymore. So NPC and entities go away. And we need to adjust the engine for the change. So now it's just event handler, game map, and player, which we've got right here. We could remove the part in engine render that loops through the entities and renders the ones that are visible. That part will also be handled by game map from now on. This is actually quite a bit of a change. Now, I'm getting into this danger of sort of applying these sort of brainlessly, but I think I have enough of a sort of a hand wave on what's going on to sort of say, okay, yeah, this makes sense. So I might want to see specifically how this winds up working. But in this case, the engine is now just rendering the map. We can move this block into game map render, though take note that the line that checks for visibility has a slight change. It goes from if self game visible entity X entity Y to if self visible right, because we're not checking inside the game map anymore. That makes sense. Okay, so def render. So we've got the shroud here for entity and self entities. Nope, that's not right. So again, here we're just unpacking the entity that we're looping through and taking out all the little goodies inside. I'm mad it made me spell color without a U. Okay, so it looks like it's complaining about this. Looks like I'm missing parentheses. Whoops. Okay, finally we need to alter the part in generate dungeon that creates an instance of game map so that the player is passed to the entity's argument. Hang on, this is already game map. No, generate dungeon. Okay, so game map. Right. Now this is interesting. So this is a list with a player in it as opposed to a tuple. I guess it doesn't really matter. But if we had, let me just see here. Excuse me. I mean, it's an iterable. I'm going to go rogue. I like tuples. Oh my God, he's got insane. If you run the project now, things should look the same as before, minus the NPC that we had earlier for testing. So we'll take a quick minute here and just make sure. Oh, there we go. Entity object is not iterable. I was not expecting that. So game map 16. Okay, so we removed entities from the engine. Didn't have a problem with a set of entities there. This is in game map, so game map iterable entity. I wonder if, oh, you know what? Maybe this is about the... That'd be weird if it was, but it would not the first time that I've... Huh! So I guess it thought I was trying to make a generator? Neat. This is why I kind of like doing little little experiments like that, just because I always wind up... I mean, I feel like an idiot when it doesn't work out, but... it teaches me why some of these things are built the way that they are. I realize I'm the only one benefiting from it. This is a video that's going out to the public, so people may not appreciate the blind alleys that it goes down. But you know what? I'm learning. Hopefully people can avoid my foolish mistakes. If I really wanted to make it a tuple, obviously there's a tuple function that I can call, but I'm not that married to it. I mostly just wanted to see what would happen. Okay, so if you run the project now, things should look the same as before, minus the NPC that we had in earlier testing. Now moving on to actually placing monsters in our dungeon. Our logic will be simple enough. For each room that's created in our dungeon, we'll place a random number of enemies between 0 to a maximum 2 for now. We'll make it so that there is an 80% chance of spawning an orc, a weaker enemy, and a 20% chance of it being a troll, a stronger enemy. In order to specify the maximum number of monsters that can be spawned in a room, let's create a new variable, max monsters per room, and place it in main.py. We'll also modify our call to generate dungeon to pass this new variable in. And again, I'm assuming a lot of this stuff is going to wind up in a separate file at some point. So max monsters per room 2. And under game map, putting that just ahead of player. And of course, game map doesn't have this yet, so presumably that's our next destination. Pretty straightforward. Now we'll need to modify the definition of generate dungeon to take this new variable. Well, shows what I know. So after map height, easy enough, but how do we actually place the enemies? Am I missing something here? Why don't we need to do this in... Because it's in generate dungeon, so we don't actually need to touch game map. My bad. Okay, easy enough, but how do we actually place the enemies? After we've created our room, we'll want to call a function to put the entities in their places. Let's call the function place entities, and it will take 3 arguments. The rectangular room that we've created, the dungeon, so that it can add the entities to it. Remember that the dungeon is an instance of game map, which now holds entities, and the max monsters per room, so that we can know how many monsters to make. Well, we haven't written the function yet. Let's place our call to it in generate dungeon. So after dungeon tiles, place entities. Now let's write the place entities function so that it actually works. Our first version of place entities won't actually place the entities. Why not? Because we'll need to do a few other things to make spawning the entities here work. However, we can at least fill in the most basic function and skip over the part that actually creates the entities for the moment. Create the function like this. So that comes under rectangular room. Or does it? We start with rectangular room. It's just above tunnel between. Again, I think it's weird that it didn't start me off tab that way. That's usually an indication that something's wrong. Okay. So, sorry, I've been kind of quiet on this. So place entities, first of all, we're going to place entities into a room, so it makes sense that we have a room which is a rectangular room. As the tutorial mentioned, we need the game map because otherwise the entities aren't going to be added to the game map. And we need maximum monsters basically so that we can know how many we can potentially generate. So first of all, we want variety. So in this case, it's pulling a random integer from 0 to the maximum number of monsters. I can never remember if this one is inclusive or exclusive. So, and this does not tell me for some reason. Something for me to look up later. So it's possible that, well, no, if it's giving 2, that would just mean that there's only one, there's just one enemy each time. So that would be not very interesting. So I guess it would be inclusive for the integers. So 0 to 2 monsters. Once it picks the number of monsters, we go range number of monsters. So for I, actually, that's interesting. So if it says for I in range of number of monsters, well, if it's 0, it doesn't have anything. So it ends at 0. So if there's 1, right, no, this still works. Okay, so it will place the number of monsters equal to number of monsters, iterates over it. So it picks a random point. So x1, I believe, is the origin for rectangular room. Yes, it is. So we start in the top left, not including the wall. Yeah, okay, so it's the boundaries between the x and the y, so it can be somewhere within the internal. I was wondering whether or not the inner would come into effect here, but I guess it doesn't. Maybe that's an extension to see if there's a way to take advantage of inner in this, or if it just makes sense to do the random draw. If not, any entity x. I'm assuming that this is to stop 2 entities from spawning at the same time. So take a look at all of the entities, make sure that their x and y's don't match, and that's both of them. Random less than 0.8, pass, to do, else. Okay. The first line in the function takes a random number between 0 and the provided minimum, or maximum, 2 in this case. From here, it iterates from 0 to the number. We select a random x and y to place the entity and do a quick check to make sure that there's no other entities in that location before dropping the enemy there. Actually, this is an interesting question. So if it's not already there, it seems to me like it just doesn't get added. As described earlier, there should be an 80% chance of there being an orc and 20% chance for a troll. For now, we're using pass to skip over actually putting them down because that requires a bit more work first. There's a few ways that we could go about creating the new entities. Assuming that every orc and troll we spawn will always have the same attributes as their brethren, we can create an initial instance of orc and troll, then copy those every time we want to create a new one. Why not just create the entities right here in the function? We could, the first version of the tutorial does in fact, but it's a bit of a pain to go back and edit. Imagine if you had 100 enemies in your game at some point in the future. Would you rather search for those entity definitions in one file that only exists to define entities, or try finding it in the file that generates our dungeon? Not to mention, what happens if you want to create a new dungeon generator? Are you going to copy over the entity definitions and have them defined in two places? Let's modify entity to prepare for this new copying method. Modify entity.py like this. Okay, so from future, import annotations, copy, and we're adding new types. This is the first time we've done something other than entity, I think. And this is an exciting one, type var, so I think this is like a generic type. I remember reading something about this in the manual, but actually no, because this was related to something else. Anyways, doesn't matter. This is maybe something I want to check out at a later. The preferred way to construct a type variable via the dedicated syntax for generic function. Okay, no, this is generic. Again, I want to check this out on my own at some later time, but it's not necessary for this tutorial. So we're blowing up entity. So self x stays the same, but we're giving it an initial value of 0 now. So sorry, I don't know if I remember this. I said this before, but when you have the equals sign, so this is giving it a default. So if we don't pass entity anything else, it will always start at 0, 0, which presumably means that it's going to be in a wall. This is actually not a bad addition as well. So if we see a question mark on the screen, that's a nice little indication that we forgot to give it a look, give it a specific specific character. Oops, looks like I don't have my num lock on. So now we're naming our entities. So I have to imagine here that with blocks movement, this is probably going to be about items. So I have to imagine in future we're not just going to be adding monsters, but we're probably going to be adding power-ups. And so it would make sense that a monster blocks your way. I mean, that is essentially what monsters do in video games. But you wouldn't want something like a potion to be in front of the door and be like, nope, sorry, you can't advance without, without drinking the potion. Or maybe you do, but that would be a little bit different from what I think expectations would be. So we've got a couple of new parameters to add. And we have a new method to add, it looks like. So I wonder what the difference between T and entity is in this case. Not span, spawn. So I can never remember deep and shallow copies. I think in this case, it sort of goes through everything contained inside of the entity. So I think if you have like collections and things like that, it copies absolutely everything. Whereas a shallow copy, I think it just keeps references that were present. Generic, shallow, or deep copying operations. A shallow copy constructs a new compound object and then, to the extent possible, inserts the same objects into it that the original contains. A deep deep copy constructs a new compound object and then recursively inserts copies into it of the objects found in the original. Right. So I believe a deep copy, if I were to have let's say an inventory, and I had a shallow copy, presumably if something gets added to the inventory in a shallow copy, the thing that was copied would also get that item, which is not so good. And then, of course, if it loses it, basically you'd have two identical backpacks for what you would want to be independent creatures. So in this case, the deep copy is what makes sure that a completely separate entity is created. We've added two new attributes to entity, name and block's movement. Name is straightforward, it's when an entity is called. Block movement describes whether or not this entity can be moved over or not. Enemies will have block's movement set to true, while in future things like consumable items and equipment will be set to false. Okay, so that's exactly what that's for. Notice that we've also provided defaults for each of the attributes in the init function as well, whereas we were not before. This is because we'll soon not need to pass x and y during the initialization. More on that in a second. The more complex section is the spawn method. It takes the game map instance along with x and y for locations. It then creates a clone of the instance of entity and assigns the x and y variables to it. This is why we don't need x and y in the initializer anymore. They're set here. It then adds the entity to the game map's entities and returns the clone. This new spawn method will probably make a lot more sense by putting it to use. To do that, let's create a new file called entityfactories.py and fill it with the following contents. I can imagine a situation where I would define a bunch of color constants, but I guess I'd need to import them too, so... Okay, so it's fairly self-explanatory, makes these entities. This is where we are defining our entities. Player should look familiar, and orc and troll are not all that different, besides their characters and colors. So I think the idea here, and again, I think the tutorial sort of explained this, but this is really crystallizing in my head now, so that basically you start off, if we were to, so we have all of these different entities. The more ideas I have for creatures, I can just keep adding these into the entity factories. And so these are all sort of made. And then what I do is there's sort of I guess technically like one of everything exists in the game world in the sense that these things get created. But for them to actually get added to the map, these copies are being made. And so essentially a clone of the orc, a clone of the troll is being added. And if there's more than one, again, these are separate entities once they get cloned, the deep copies. But effectively, there's always somewhere in the background an orc and a troll that's unkillable that's running around. I think that's how this is working. Okay, this is where we're defining our entities. Players should look familiar, and or control are not all that different, despite besides the characters and colors. These are the instances we'll be cloning to create our new entities. Using these, we can at last fill in our place entities functions back in procgen.py. I need to add the import, but I'll get that in a minute. Wait a minute. Yep, no. That should fix, those problems. Let's also modify the way we create the player. So that's in main. Nope, that's engine. Okay. After event handler, we go okay, nope, that makes sense. I'm curious why, so why doesn't it do spawn? I'm sure there's a very good reason why it doesn't do spawn, but so we spawn, we do a deep copy of the self. I guess it's because we need to give it an initial X and Y. But we don't give an initial X and Y to the player, so that shouldn't matter. I know when we generate the map, it basically assigns an X and Y to it anyway, but I'm kind of curious why we don't bother doing the spawn when... Well, I guess it's because when we spawn, we give it an X and Y. Like, it expects values there. So maybe that's, as good of a reason as any. No, we can't use player... Oh, it says, so we can't use player spawn here because spawn requires the game map, which isn't created until after we create the player. Right, I was looking in the wrong spot. So self game map X and Y. So we could just give it arbitrary X's and Y's, but that's absolutely right. The map gets made after here, and it requires a player. Okay, I like that they included the note. So I've noticed, by the way, like when it comes to this, I did say I was a little worried about sort of going on autopilot for a couple of these, but this is also one of the examples where it's like, maybe we can do something here. And so I always kind of like, okay, the tutorial's explaining something to me, and I feel like I had a good handle on that. In this case here, this is one of the examples where the tutorial clarified something, and I was like, oh, I actually thought we could do something different. Obviously, there were also those cases where I didn't do the square brackets. I did the parentheses instead, and that caused a problem. But this is a case where the tutorial specifically said, hey, dummy, you can't do that. So that's fine. That's what learning's about. With that, your dungeon should now be populated with enemies. So let's see if this works. No. Random rand. Now that's interesting, because I thought that was... That's an easy change. Nope. It was random, so... sorry, where was this? 53. Maybe I was expecting the tab complete? I don't know. Like I said, though, easy fix. Okay, another. So cannot access free variable x where it is not associated with a value in the enclosing scope. That's a little more complicated, so still in procgen. So let's see if we can fix this before we look at the code, although I sort of doubt it. So this is the one where we are trying to avoid duplication, I think. This is line 52. Okay. Now, how much you want to bet it's solved with a tab here? Because we had x and y defined here. If I go outside the 4... Yeah, because if I don't do that, then we're not doing that for every monster. So that was a simple tab problem. All right, so there's an orc. Interestingly enough, it's not blocking me, but then we didn't provide any functionality to stop it from blocking me. There's another orc. There's a troll. There's an orc. 2 orcs. Very unlucky room. Orc and troll. Nothing in here. Soul orc. Nothing. I thought the troll might be a different color. I guess it's a little greener. Okay, nothing in this room. I mean, we obviously already know it works, but I'm still in the honeymoon phase of thinking this is interesting to look at as you go through. Okay, so that's working as intended. They're not exactly intimidating, are they? In fact, they don't really do much of anything right now, but that's okay, we'll work on that. The first step towards making our monsters scarier is making them stand their ground, literally. The player can currently walk over or under the enemies by simply moving into the same space. Let's fix that and ensure that when the player tries to move towards an enemy, we attack instead. To begin, we need to determine if the space the player is trying to move to has an entity in it, not just any entity. However, we'll check to see if the entity has blocks movement set to true. If it does, our player can't move there and tries to attack instead. Add the following to the map. Okay, so we're adding optional. And under game map, we have init get blocking entity at location self location x, which is an integer, location y is an int, and presumably it's returning either an entity or nothing. Yep, optional entity. So for entity in self entities, so this is checking the whole map. Entity blocks movement, and entity x is at location x, and entity y location y. Otherwise, we return none. All right, this new function iterates through all of the entities, and if one is found that blocks movement and occupies the given location x and y coordinates, it returns that entity. Otherwise, we return none instead. Where can we check if the tile is occupied or not, and what do we do if it is? Well, presumably we'd do this in the same place where we move. One way to handle all of this is to modify our actions a bit. Our current movement action doesn't take into account what occupies the tile we're moving into. That's fine, it doesn't necessarily need to, but there probably should be an action that does. What if we created an action subclass that could tell what was in the tile and call either movement action if it was empty or some other attack action if it wasn't? Let's do a few things. We'll start by defining a new class called Action with Direction, which will actually become the new superclass for movement action. This new class will take the initializer from movement action but won't implement its own perform method. It looks like this. There's actions. I'm also getting a little hungry, so I'm kind of happy we're getting close to the end here. Okay, so after escape action, we add the superclass. So I think this is the first we've seen super here. So essentially this is saying, give me the init from action. Now self dx equals dx, self dy equals dy, and def perform easy enough. So now we change this to inherit from action with direction. It is worth noting, right? So as you go, as you inherit from action with direction, this is still inheriting from action, just indirectly. So we're adding the dx and dy here. So with direction, so we're getting rid of the, oh, and my bad, apparently we did have a super in it before and I just didn't pay attention. Actually, we get rid of the full init. And then below that, engine, game map, get blocking entity at location. One of my comp sci profs used to make fun of me for giving long names like that. I don't know how I feel about the blank returns. I mean, I guess it's fine. It does say none, but it feels a little weird to just return nothing. Something for me to meditate on later. I suspect these will change well, no, actually, I guess it is just going to return. I'm sure it's fine. Notice that we've added an extra check in movement action to ensure that we're not moving into a space with a blocking entity. Theoretically, this bit of code won't ever trigger, but it's nice to have there as a safeguard. Sorry, let me just double check that. We've added an extra check in movement action to ensure we're not moving into a space with a blocking entity. Theoretically, this bit of code won't ever trigger. So why isn't this supposed to trigger? Is it because we're doing some sort of an attack? Right, we probably just haven't implemented the thing that would cause it to trigger. But it's nice to have there as a safeguard. I guess it might be nice to have as an else if too, but anyways. But wait, movement action still doesn't do anything differently. So what's the point? Well, now we can use the new action with direction class to define two more subclasses, which will do what we want. The first one will be the action we use to actually attack. It looks like this. So melee action, which we will do immediately following action with direction. Perform. There's the get blocking entity at location. I don't quite see how we know how to call melee action yet, but presumably we add that later. If not target. Does So this is a trick we were talking about before, right? If there's a null, it has there's a truth value associated with it. Return. So this is a neat little thing. So if you're not familiar with these in Python, this is an F string. So sometimes you may have seen something like I guess you kind of need to add one of these things in as well. So that format style I've seen in C. I'm sure it gets used in other instances. But in the case of Python, you can actually put an F in front of a string, and basically you include a variable inside the braces here, and that will fill it in with whatever the string representation is. Very helpful. And you can do things like specify spaces and so on and so forth. But I prefer this to calling format. It's just, I think, a nice little concise way of doing it. And I've used it a few different times just to make things a little bit easier for people. Because, again, my context here, even though I'm very much learning myself, very often I'm going to be writing things for people who are even less familiar than I am. And so it can often be helpful to try and put things in ways that even if they've never seen Python before, they sort of feel like they have a fighting chance in order to be able to understand what's going on. And my feeling is that if you have the friendly little F in the front here, it's a little more helpful than saying it's like, oh, okay, what were these braces for? Okay, I'm going to match that to this side and then this side. And this. I mean, not that I have like a billion formats, but anyways, just a little thing that I like. Just like movement action, melee action inherits from action with direction. The perform method it implements is what we'll use to attack eventually. Right now, we're just printing out a little message. The actual attacking will have to wait until the next part. This one is getting long as it is. Still, we're not actually using melee action anywhere. Okay, that was anticipates what I was talking about above. Anywhere yet. Let's add one more class, which is what will make the determination on whether our player is moving or attacking. So bump action, which comes after movement action. F perform, self engine. To none. Engine game map get test. It's basically if there's a bad guy there, do the melee action, otherwise do movement, I think is what this is saying. Yep, that's fine. Okay. This class also inherits from action with direction, but its perform method doesn't actually perform anything except deciding which class between melee action and movement action to return. Those classes are what are actually doing the work. Bump action just determines which one is appropriate to call based on whether there is a blocking entity at the given destination or not. Notice we're using the function we defined earlier in our map to decide if there is a valid target or not. Now that our new actions are in place, we need to modify our input handlers.py file to use bump action instead of movement action. It's a pretty simple change. And in fact, I think I get to be a little clever here. So we can go into, sorry, what was this again? Input handlers. So we are replacing movement action. Oh. Well, I'll do the right order here. So obviously all of these are now get red underlines, but one thing that's nice about this is I can highlight it. I can hold Control, Shift, and L. It's all changed in the same spot. So one thing I like, obviously this is not exclusive to VS Code, but it's something that I've gotten used to doing, which is to me very helpful. Okay. And yeah, it's just a straight switch from movement to bump, so we're good there. Run the project now. Let's see, before we do anything else. Sorry, I have a lot of these open. I usually like to just review these at the end of the session to make sure that there weren't any lingering questions that I had before. So, did we do anything with tile types? Doesn't look like we did, so I guess I'll close that. No, sorry. I will reopen that. I guess I didn't really need to do that right now, but I was taken by a sudden urge. Okay, no crashes. That's good news. So we've got some orcs that we can kick the shins of. You kick the orc much to its annoyance. Now I have no reason to think that that it will behave any differently with a troll, and we're banging into the wall. Nothing happening there. But I am going to see if I can find a troll just to see the variation in the name. It's a little bit like, you know, using all of the arrows. So in addition to liking the process of exploring the maze, it also gives me a chance to test all of the directions. Now, again, I'm assuming that this tutorial is not really designed to turn you into a full-on software developer. Oh, this is interesting. They're blocking the way. You know, one thing that I would probably want in a case like this, you kick the troll much to its annoyance. One thing that I'd probably want here would be to have a bunch of sort of unit tests set up. And maybe that's actually an extension that I can give for myself at the end, in addition to any extensions to the... Actually, yeah. So now we're getting close to the end of this session, so maybe it's not bad to do a little bit of planning. There's a couple of things that I think I'm going to want to do. So number one, when I complete the project, so I want it to be sort of running and at the sort of the finished state that the tutorial would have it. And ideally, we've done whatever extensions or whatever changes we think are appropriate, you know, especially dealing with those future warnings, etc. But maybe one thing that would be a nice extension, which doesn't really relate to making this a game, but it might actually not be a bad idea to just go in and add doc strings and tests and otherwise just sort of fill out all of the details that if you read a book, it sort of tells you, hey, these are good things to do. And then after that, what I can do, if there's time, maybe what I would do is I'd say there's the event that's going on, right? RoguelikeDev does the complete roguelike tutorial. I'm thinking maybe what we do there is whatever time I have between that extension of the tests and whatever the official end of the event is, that'll be the time for me to add new things. And whether that's changing colors or that's, you know, trying to add new gameplay or something like that, that might be a nice little exercise in trying to learn scope. To, you know, say, all right, I want to put a stamp on this to make this mine, but I need to make sure that I do so in whatever time I have left over between finishing this project and, or between implementing the things that I want and then getting to the end of the event. Now, of course, where I am right now, I'm a couple of days early on finishing next week's work. So I do have a few other things that I need to do this week. So, you know, I'm not expecting to get too far ahead, but I think that might be a useful way of thinking thinking about this project, just so that it doesn't become a forever project, but it does give me opportunities to sort of think about how to extend this. Because obviously, I mean, it's worth just learning to do this stuff on its own, right? It's like learning to do your own, encryption algorithm or something like that. You're probably going to get yourself in trouble if you actually try to use that in the real world. But if it's something just so that you can learn a little bit about how these things work and how people think about these problems, sometimes just satisfying your curiosity is reason enough. But we're not actually quite finished yet, so let's get to the end of the tutorial. Before we wrap up this part, let's set ourselves up to allow for enemy turns as well. They won't actually be doing anything at the moment, but we'll just get a message in the terminal that indicates something is happening. Add these small modifications to engine.py. So handle enemy turns, which is just below init. Whoops. So go over all of the enemies, remove the self player from the list. So sorry, we're not removing it from the list, but we are cycling through the entities for things that are not the player. This is actually a cute little bit of text. So in terms of extensions, this might be a fun one where if you can include something that gives the thoughts of the entities at random moments. It's just a cute little tip of the hat to a line that I liked. Okay, and under handle events, we need to handle the enemy turns, which comes after action perform. The handle enemy turns function loops through each entity minus the player and prints out a message for them. In the next part, we'll replace this with some code that will allow those entities to take real turns. I'm sorry, my voice is getting a little scratchy, so I'm just going to sip something. I know we're almost done. Okay. We call handle enemy turns right after action performs so that the enemies move right after the player. Other roguelike games have more complex timing mechanisms for when entities take their turns, but our tutorial will stick with probably the simplest method of all. The player moves, then all the enemies move. That's all for this chapter. Next time, we will look at moving the enemies around on their turns and doing some real damage to both the enemies and the player. If you want to see the code so far in its entirety, click here. It's a GitHub repository, and click here to move on to the next part of the tutorial. So we are just going to take a minute here and make sure that everything is running. Right, that was engine, so. Okay, encouraging. So lots of things. There's 3 trolls. Yeah, 3 trolls in this level. So if I want to fill my console, I better hope there weren't any deprecation warnings. Presumably we'll see them once we remove this text, but so you might wonder, I'm bumping into this orc here. What I can do is maximize this view. So you kick the orc much to its annoyance, but just the sheer number of messages is overwhelming that particular one. So I'll just take a minute to fill out the map because this is kind of fun to do and I like wasting your time. All right, there we go. And I give that orc an unintentional kick just for good luck. seems to me like everything's working the way it's supposed to. So that was actually a pretty good session, I think. 45 minutes, so shorter than some of the previous ones. And we learned quite a bit. Like I said, I was worried a little bit earlier in the sense that I felt that I was going a bit more on autopilot. And certainly there's a couple of things that I wasn't expecting to be true that that's the game sort of, the tutorial advised on. But I'm not going to wear a hair shirt over this or something like that. The idea here really is just, it's a nice little check-in for me to make sure as to whether or not I'm on the same wavelength as the tutorial, and whether I'm, being active in terms of the way that I'm learning. Now, I don't think I have that much that I want to research on my own. Obviously, there's sort of the lingering questions in terms of how typing works. Some of the specifics in terms of the fact that, we usually check entity. There was one where we checked game map, although I think that was because we were in entity. And then I guess entities aren't iterable, and finding out, like, it could do that when it was a list but not a generator. Like, that's kind of curious to me, but not... I'm not like really wanting to go into the depths of Python to really learn how that works. Like, I'm willing to accept that I tried to do something silly and it didn't work out, and that's, that's okay. So I don't think I have anything that I will follow up for the next video. But I don't know, maybe it's a chance for me to learn about the line algorithm here, or just to do, just do other things. There's lots for me to do, seeing as I'm recording this a couple of days before it's supposed to go live. So final thing that we'll do, I'm not really going to talk about all of the different things that we added, because we have a lot, right? We added new enemies, we added interactions and attacks. So I'm just going to say completed part 5. And then in this case, we're going to commit and say, oops, yes, take everything. And then we're going to push that to main because we finished the day's work. I think there's a way to see the history of the project. You might need another extension for that, but something for me to think about later. But yeah, that's it. Thank you everybody for watching. I hope some of you, I noticed there were a couple of comments between when I put up the first video and recorded this one. So I hope there's a couple of you that have decided to try this tutorial yourself. If not, I am glad that you have stuck through to this point here. It's always nice to have people watch. But until next time, have a wonderful evening, and we'll see you in the next one. Take care.